Hello guys, today we'll be looking at what? Discrete probability distribution. We are going to start with Bernoulli distribution. What did I say? Bernoulli distribution. So in many real life experiments, we normally have what? Two possible outcomes. For instance, if a student takes a test, it's either he or she pass or he or she what? Fail. And if a project is being inspected, it's either that project is what? Defective or it is what? Good. And also if a coin is tossed, it's either you obtain what? A head or you obtain what? A tail. So all those experiments that have only two possible outcomes are called Bernoulli experiment. What did I say? An experiment with only two possible outcomes is called Bernoulli experiment. And we normally denote those two possible outcomes as what? Success or failure. What did I say? We denote those two possible outcomes as success or failure. The probability of success is denoted as what? Probability of success is denoted as P, while probability of failure is denoted as 1 minus what? P, which is the same thing as what? Q. So the probability of success is denoted as P, while the probability of failure is denoted as what? Q. Now, a random variable generated from a Bernoulli experiment is called a Bernoulli random variable. What did I say? A random variable generated from a Bernoulli experiment is called a Bernoulli random variable. Okay? So let x be a random variable from a Bernoulli experiment. Let x be a random variable from a Bernoulli experiment with probability of success P, and what? Probability of failure denoted as Q, which is equal to 1 minus what? P. So let S be a random variable from a Bernoulli experiment with probability of success P and probability of failure denoted as what? Q. This P and Q are what? Are constant. We call them parameters. So now if this happens, we say that X follows a Bernoulli distribution if the probability of capital S equal to small x is equal to what? P raised to power x, Q raised to power 1 minus x, where x is equal to what? 0, what? 1. So x can only take what? Two possible values, 0 and what? 1. This 0 is the probability of failure, while this 1 is called the probability of what? Success. So for x is said to what? To follow the Bernoulli distribution if the probability of what? X is equal to what? P raised to power x multiplied by what? Q raised to power 1 minus what? X. Okay? So we'll be looking at what? Expectations expectation, variance, and what? The moment generating function of a Bernoulli distribution. What did I say? The expectation, variance, and moment generating function of a Bernoulli distribution. Now, in our previous class, I told you that expectation of x, expectation of a random variable, is equal to what? For a discrete distribution, summation over the range of what? X multiplied by what? Probability of what? X. Now, so the expected value of what? The expectation, comma, variance, and moment generating function of a Bernoulli distribution are P, PQ and P exponential what? T plus what? Q respectively. So the expectation, variance, and moment generating function of a Bernoulli distribution are P, PQ, and what? P exponential T plus what? Q respectively. So we'll be proving why expected value of what? X of a Bernoulli distribution is equal to P, and while its variance is equal to what? PQ, and while its moment generating function is equal to what? P exponential T plus what? Q. Okay, let's start with what? The expectation. So we are trying to prove why expected value of x of a Bernoulli distribution is equal to what? P. Expected value of x is equal to what? Summation as x equal to what? 0 to 1 of x multiplied by what? Probability of x equal to what? Small x. And for a Bernoulli distribution, we define our P of probability of x equal to small x is equal to be what? To be P raised to power x Q raised to power what? 1 minus what? X. So, and the range of x is from what? 0 to what? 1. So the expected value of the x is equal to what? Summation as x equal to 0 to 1 of x multiplied by what? P raised to power what? X Q raised to power 1 minus x. So if you substitute the values of what? X, when x is equal to 0, you have what? When x is equal to 0, you put the value of x to be 0 here. You have 0 multiplied by what? P raised to power 0 multiplied by what? Q raised to power 1 minus what? 0 plus, when x is equal to 1, you have what? 1 multiplied by what? P raised to power 1 multiplied by what? Q raised to power 1 minus what? 1. This will give us, here is equal to what? 0, because 0 multiplied by anything is what? 0. So you have, we have 0 plus P raised 1 times P raised to power 1 times what? Q raised to power 0 will give you what? P. So the expected value of x is equal to what? P, which is what? The probability of success. So for a Bernoulli distribution, we have shown or proved that the expected value of x is equal to what? P. So let's prove or let's show how the variance of x for a Bernoulli distribution is equal to what? P Q. So for a variance of a Bernoulli distribution, we know that the variance of x is equal to what? Expectation of x squared minus expectation of x all squared. So this is the variance of what? This is the variance of what? A random variable. So the variance of x is equal to expectation of x squared minus expectation of x all squared. And you know that our expected value of x squared is equal to what? Expectation of x squared is equal to what? Summation as x equal to what? 0 to 1 of x squared multiplied by what? Probability of x equal to what? Small x. So, and for a Bernoulli distribution, our probability, the probability mass function, which is this, is given as probability of x equal to small x is equal to what? P raised to power x, q raised to power 1 minus x. So, putting it in this, we have our expected value of x squared to be what? Summation as x runs from 0 to 1 of x squared p raised to power x, q raised to power 1 minus x. So, substituting the values of x when x equal to 0, you have 0 squared multiplied by what? P raised to power 0 multiplied by q raised to power 1 minus 0 plus what? When x is equal to 1, we have 1 squared multiplied by what? P raised to power 1 multiplied by q raised to power 1 minus 1, which will give you 0 plus what? P, which is equal to what? P. So expected value of x squared is equal to what? P. But we know that variance of x is equal to expected value of x squared minus expected value of x all squared. So we have gotten our what? Our expected value of x squared to be what? P, and the expected value of x to be also what? To be P. So we have that variance of x is equal to what? P minus what? P squared. So these they have P in common. So we bring 1P out. We have P is equal to what? This is equal to P bracket 1 minus what? P. And initially I defined our Q to be what? 1 minus what? P. So this implies that variance of x is equal to what? P Q. So we have shown that the variance of x is equal for the variance of x for a Bernoulli distribution is equal to what? P Q. So if you are finding it difficult on how variance of x is equal to expected value of x squared minus expected value of x all squared, how this is equal to this, you can drop it in the comment section so that I can help you out. So let's show why the moment generating function of a Bernoulli distribution is equal to what? How the moment generating function MGF of a Bernoulli distribution is equal to P exponential t plus what? Q. So I'm trying to prove why the moment generating function of a Bernoulli distribution is equal to P exponential t plus what? Q. where this t is greater than or equal to what? Minus infinity and less than or equal to what? Infinity. So let's start. The MGF, we denote MGF, which is called moment generating function, to be what? To be mx of what? T, where this t is a real number. So this is how we write MGF of any distribution. So, and it is defined as what? It is defined as mx of what? T to be what? Expected value of what? Exponential tx. This is how we defined the moment generating function of any distribution. It is defined as what? Expected value of exponential what? Tx, where this t is what? A real number. So let's, for a Bernoulli distribution, we have that the probability of x, which is the probability mass function, to be what? P raised to power x, q raised to power 1 minus x. So our MGF now is equal to what? Summation as x equal to 0 to 1 of what? Exponential tx multiplied by what? Probability of x equal to what? Small x. This is equal to summation as x equal to 0 to 1 of exponential tx multiplied by what? Q raised to power x multiplied by q raised to power 1 minus what? X. So this is equals to summation as x equal to 0 to 1 of what? These have x in common, so we have bring them together. P exponential t raised to power x multiplied by what? Q raised to power 1 minus x. So this will give us when we put the value of x to be 0, we have what? P exponential t raised to power 0 multiplied by what? Q raised to power 1 minus 0, plus when the value of x is equal to 1, you have our P exponential t to be what? 1 multiplied by q raised to power 1 minus 1. This will give us when this is equal to 0, here is equal to 1, and here we have what? Q plus what? P exponential t. This is also equal to what? P exponential t plus q. This is the moment generating function of the Bernoulli distribution, and this t is greater than or equal to infinity and less than or equal to negative infinity. Thank you. So in our next class we'll be looking at what? Binomial distribution.